like and leave a comment, and share the video to help spread this free series of videos. Thanks for your help. In this video, we will cover two Cisco proprietary protocols, DTP, aka Dynamic Trunking Protocol, and VTP, VLAN Trunking Protocol. As I said, they are Cisco proprietary, meaning they were developed by Cisco and they only run on Cisco devices. DTP and VTP were removed from the CCNA exam topics list for the new exam, 200-301. However, it's important to know their function, and you may still get questions about them on the exam, even though they are not on the topics list. So, what will we cover in this video? Well, I already said it. We will cover DTP, Dynamic Trunking Protocol, first. DTP is a Cisco proprietary protocol that allows switches to negotiate the status of their switch ports, be either access ports or trunk ports, without manually configuring them. Then we will cover VTP, VLAN Trunking Protocol. VTP is another Cisco proprietary protocol that allows you to configure VLANs on a central switch, which then acts as a server that other switches can synchronize to, so you don't have to configure VLANs on every single switch in the network. Also, make sure you watch until the end of today's quiz, as I will once again feature a question from XSIM for CCNA by Boson Software. XSIM for CCNA is Boson's set of practice exams for the C. If you want to, let's go over some points about DTP. DTP is a Cisco proprietary protocol that allows Cisco switches to dynamically determine their interface status, access or trunk, without manual configuration. Basically, two Cisco switches connected together can form a trunk, but otherwise the interface will automatically be an access port. Basically, two Cisco switches connected together can form a trunk, but otherwise the interface will automatically be an access port. DTP is enabled by default on all Cisco switch interfaces. Once again, because it is a proprietary protocol, this applies only to Cisco switches. So far, we have been manually configuring switch ports using either switch port mode access or switch port mode trunk. If we use DTP, you don't need to enter these commands. Now, for security,
Devices are pre-configured from the end of day 17 lab. Switch 2 has been replaced by a multi-layer switch. Hosts are in the correct VLANs. Switch 1 switch 2 are connected via trunk R1. Switch 2 are connected via the runner stick. Place the runner stick configuration on R1 with a point-to-point layer. is the IP address given a network diagram. Figure a default route on switch 2 with R1's D00 interface as the next hop. So the configurations will be no interface, the show IP display, so and do show IP interface brief. Okay, no face geek. Um, and this is the address .0.0. Five 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 two five plus berapa nih? Plus 252 plus is the IP address given network diagram. Configure default route on switch 2 with R1 C00 interface as the next hop. Configure SVIs on S21 for each VLAN. Send the last usable IP address of to get SVI. We will reconfigure the R1. We will configure the switch 2 interface. Enable the no switch port. Switch. Space D102 no switch port. No switch port. We want IP address press and .0.0.193 255.255.255.252 and you have to route route connected and local. We have to add the static route in here, so we IP route and send the last usable IP address of which I'm create SPIs. The next route. Lupa aku anjing.
Welcome to Jeremy's IT. The subinterfaces still appear here. They are immediately removed in packet tracer. Now let's configure G00 with an address config, which requires the switch port trunk encapsulation.1q command. The model of switch used in the previous lab configuration, default interface, or I had to do 102. When testing this lab out before, I had to do the command twice for it to work. That might be a packet tracer issue, but I'll issue the command once more by using the up arrow. And next, let's check. Do show run. Immediately removed in packet for eWitness. So the subinterface conf t status of the interfaces. Show IP interface 3. G00 and its subinterfaces are all up. Now let's remove the sub. 20. So show IP tracer S3 is just with this. They are immediately removed in rest. Interface G00, IP address 10.0.0. Default interface G has the default settings. 02 interface. And what the previous lab didn't require this. Okay, let's return the interface to the default configuration. Enter global config mode, conf t. When testing this lab out before, I had to do the command 02. Default interface G102. When testing this lab out before, I had to do the command twice for. Okay, so G102 is configured 02. That is no option for address. Now we have, try again. IP, then question mark. 255.252. Finally, let's configure the default route here. The connected and local routes. And let's view the routing table once only a connected routes appeared properly. Connected and local. O.10.0.0. route. R1's address. Route has been added. Is to check if it's fairly simple. Usable address of the subnet in this. IP address 10.0.0.62. IP address 192. Finally, VLAN 30. Interface VLAN 30. IP address 10.0.0.1. Interface VLAN 30. IP address 10.0.0.190. 255.255.255.192. Exit. Now let's check if the interfaces are up. Do show IP interface 3. Okay, well, our entering VO2 piece.
Now we go into So time there was no uh, so I do
Even though in the previous lab, in cap once G one's IP this and finally FX. Since published the config they report trunk in the base of the config
do show run
configurations have
which port
be there is no option for address. Why is to do the core
default D1 2 2 have to assign the IP address this and this and press Alex out get out 0.0.0 0.0.0 0.0 out here configure the SPIs uh, s- 62 5 S um, and 6 006 to and mine will be the last two IP address. Itu and so I think the Facebook. Now we have to test it. Post. Facebook. If I have to ping in here, it will be successful because yes, routes all the IPs on the through G01 to interface, G00 interface to internet interface.
I had to do the command. So take note of these last 4 digits, 353. Step 2 is to configure the connection between switch 1 and switch 2 as a trunk, and allow only the necessary VLAN. We should configure an unmute. Step 1 says to configure the switch interfaces connected to PCs as access ports in the correct VLAN. I'll go on switch 1 first. Enter privileged exec mode with enable, then global config mode with configure terminal. So there are 2 PCs in VLAN 10. Let's configure those first. Interface range F01 to 2. Port mode access. Switch port access VLAN 10. And the switch creates VLAN 10 for us. Okay, that's all for these hosts. Next up, VLAN 30. Interface range F03 to 4. Switch port mode access. Switch port access VLAN 30. Once again, the switch creates the VLAN for us. Okay, that's all for switch 1 for now. Next, let's go on to switch 2. Enter privileged exec mode with enable, then global config mode with cont configure terminal. I'll configure VLAN 20 first. Interface X01. Switch port mode access. Switch port access VLAN 20. Next, VLAN 10. Interface range X02 to 3. Switch port mode access. Switch port access VLAN 10. Okay, step 1 is complete. Step 2 is to configure the connection between switch 1 and switch 2 as a trunk, and allow only the necessary VLANs. We should configure an unused VLAN as the native VLAN, and also make sure all necessary VLANs exist on each switch. I'll return to switch 1 now. Okay, let's configure the interface. Interface G01. If you remember from the lecture video, in some switches we have to use the switch port trunk encapsulation.1q command before configuring the interface as a trunk. Let's see if we have to do that here. Port trunk, then use the customer. As you can see, there is no option for encapsulation. This isn't a case of packet tracer not supporting the command, but rather it's because this switch itself only supports .1q encapsulation. As I mentioned in the lecture video, modern switches often don't support Cisco's ISO, since the industry standard .1q is used almost exclusively. So we can go straight to the next command, switch port mode trunk. Now let's allow VLANs 10 and 30. Switch port trunk allowed VLAN 10, 30. Why don't I need to allow VLAN 20 on this trunk? I already explained this in the lecture video, but it's because no hosts in VLAN 20 are connected to this switch. If PC5 in VLAN 20 wants to reach any host here, its traffic will be sent to the router first, which will send it back to switch 2 in VLAN 10 or VLAN 30, which will then send it over to switch 1. Watch the lecture video again if you want a more detailed explanation. Okay, finally, let's set the native VLAN to an unused VLAN. Port trunk native VLAN 1001. You can use anything here, just use an unused VLAN. Now, do all of the necessary VLANs exist on this switch? Let's check. Do show VLAN brief. We have VLANs 10 and 30. Looks good. We don't need to create any more VLANs. Okay, now let's go to switch 2. Interface G01. The configurations will be the same as on switch 1. Switch port mode trunk. Switch port trunk allowed VLAN 10, 30. Again, VLAN 20 doesn't need to be allowed. There are no VLAN 20 hosts connected to switch 1, so switch 2 doesn't need to send VLAN 20 traffic along this trunk. Okay, next set the native VLAN. Switch port trunk native VLAN 1001. Okay, that's all for the configuration of the trunk. Now, do all necessary VLANs exist on the switch? Do show VLAN brief. We have VLANs 10 and 20. Let's do another show thing. Do show interfaces trunk. So VLANs 10 and 30 are allowed on the trunk. Good. However, look under here. VLANs allowed and active in management domain displays only VLAN 10. That's a problem. It means switch 2 won't actually receive VLAN 30 traffic on this trunk. That's because VLAN 30 doesn't exist yet on this trunk. VLANs 10 and 20 were automatically created when we configured access ports in those VLANs, but VLAN 30 wasn't created. So let's make it. VLAN 30. Fix it. Do show interfaces trunk. Okay, now you can see that it appears here. That's all for step 2. Step 3 is to configure the connection between switch 2 and R1 using router on a stick. Let's quickly do the configuration here on switch 2 first. It will be mostly the same as the G01 trunk, except we must allow all 3 VLANs. Interface G02. Switchport mode trunk. Switchport trunk allowed VLAN 10, 20, 30. Switchport trunk native VLAN 1001. That's all for the switch. Now let's go on to R1. Enter privileged exec mode with enable, then cont T to enter global config mode. First, let's enable the physical interface. Interface G00, no shutdown. As I have said many times before, Cisco router interfaces are disabled by default. Now let's configure the VLAN 10 subinterface. Interface G00.10. This subinterface number doesn't have to match the VLAN number, but we really should make it match. Okay, let's set the VLAN number itself. Encapsulation.1Q 10. Finally, the IP address, which should be the last usable address of the setback, according to the instructions. IP address 10.0.0.62, 255.255.255.192. Okay, that's it. I get the question sometimes. Why does the router address have to be the last usable address? Well, it doesn't have to be, but we should have a system you use. Either the first usable address or the last usable address as the gateway address for the subnet, so there is consistency across the network. Don't just use a random address for the router, or it will be difficult to understand things in a large network. Okay, now let's configure VLAN 20 subinterface. Interface G00.20. Encapsulation.1Q20. Once again, set the last usable address as the router's address. IP address 10.0.0.126, 255.255.255.192. Okay, finally is VLAN 30 subinterface. Interface G00.30. Encapsulation.1Q30. IP address 10.0.0.190, 255.255.255.192, which is the last usable address of the VLAN 30 subnet. So that's all of the configurations for this lab. Next up is to test connectivity. If everything is configured correctly,
I think I'm gonna try to configure this video, the VLANs part 2. I think I'm gonna download the lab because I've already configured the earlier and save that. You have to download it again. VLAN part. Now we want to configure this app without actually watching the video because I'm already watched the video on 1.5 playback speed. Now we want to configure this lab. So the steps are step 1, figure the switch interface connected to PC's access port in the correct. We go to each one here, enable that. Interface rank X01, 2, port access, port access VLAN 10, 0, 3, 4, range, switch port access, port access menu, 30. Okay, so switch to configure the correct VLANs on each interface. We type enable conf t, go to the correct interface here, type 01, switch port mode test, switch port access VLAN 20, press F0 range, switch port mode test, switch port access VLAN 10. We already configured the correct interface on each switch. And now we go to step 2. Configure the connection between switch 1 and switch 2, etc., allowing only the necessary VLANs. Configure unused VLAN as the native VLAN. Make sure all necessary VLANs exist on each switch. We configure the trunk ports. Go to E01, 0E01, switch port mode trunk, switch port trunk, out VLAN 10, and port trunk edit and edit 10 2001. Yeah, I think that's for the configuration for the switch to configure the connection between switch 1 and switch 2 as a trunk, allowing only the necessary VLANs. Configure and use VLAN as a native VLAN. To show VLAN and brief. Okay, VLAN were active on and 10 and 30 within the correct interface. However, as you can see here, for the VLAN 10 will be F01 and F02 as the interface, and for the VLAN 30, the interface will be F03 and F04 as the interface. Show interface to show interface from up in this configuration. Now we move to switch 2. The interface E01, which mode trunk for trunk allowed VLAN for the allowed VLAN. Will 10 and 30 and 10 and 1. And now we move to for the do show the brief do show around so for villains allowed on throne, villains allowed on management. As you can see here, for the port G01, the villains allowed on throne is 10 and villain 10 and villain 30. But for the villains allowed and active in management domain is only 10. So in this case, we have to create a new VLAN because on our last configuration on all access port on the switch 2, we didn't create the VLAN 30 there. We only create a VLAN 10 and VLAN 20, so we just type VLAN 30. So we see we show okay, it's all set, and now we configure the connection between switch 2 and R1 using ordered on a stick. And the last usable address on R1's figure interface G02 port mode as a drum switch port drum loud VLAN 10, 20 and 30 switch port drum added VLAN 1 exit. That's it for the configuration on switch 2, I think. Switch 2 and R1 using router stick, and the last usable address on each subnet R1's sub interface. Strong port. Really and I will enable conf to show this brief. Interface G00 connection. Interface G00.10 encapsulation .110 and IP address 110 and this the encapsulation as 0.x over 255 dot exit paste 0 encapsulate that one 30 press and the both of it. But really need to assign those IP address on ports. So yeah, assign the last usable address on its connectivity by pinging between usable. We have ping. Desktop. VLANs and it's VLAN 30 to VLAN 10. VLAN 8. This time to connect. So that's on the simulation mode. We can see the connection between through this, through this, through this, and through this. Now we're moving to DTP. DTP is Cisco proprietary protocols that allow Cisco switches to dynamically determine their interface status, access, or drone without manual configuration. DTP is enabled by default on all switch interfaces. So far, we have been manually configuring switch port using this command: switch port mode or switch mode. Security purposes, manual configuration is recommended. DTP should be disabled on all switches. DTP is Cisco proprietary switches to dynamically determine their interface status. It's either access or drone without a manual configuration. DTP is enabled by default on all Cisco switch interfaces. So far, we have been manually configuring switch port using this command. Switch port mode access or drone. Security purpose, manual configuration is recommended. DTP should be disabled on all switch port for the security purpose. Like security purpose, when you are already using OSPF for the dynamic configuration. Tab. You're using static configuration on
Security purposes, manual configuration is recommended. DTP should be disabled on all switch ports. DTP can be exploited by attackers, and I'll talk more about network security later in this course. But for now, just know that it should be disabled on all interfaces. Let's go straight into the CLI. I'm in interface configuration mode here on a Cisco switch, and I entered switch port mode, followed by a question mark. You can see the access and trunk options we used before, but the one we're going to look at now is this one, dynamic. It says, set trunking mode to dynamically negotiate access or trunk mode. That's DTP. So I entered dynamic and used the question mark again. There are two options, auto and desirable. The only description given is set trunking mode dynamic negotiation parameter to auto or desirable, which doesn't really explain their function. So let me explain each of these modes. A switch port in dynamic desirable mode will actively try to form a trunk with other Cisco switches. It will form a trunk if connected to another switch port in the following mode: switch port mode trunk, switch port mode dynamic desirable, or switch port mode dynamic auto. Let's see how that works. Switch 1 and switch 2 are connected via their G00 interface. Switch 1's G00 interface is in dynamic desirable mode. Switch 2's G00 interface is manually configured as a trunk. So these two switches will both agree to operate as trunks. Here is a new command: show interfaces G00 switch port. These are just the first few lines of output. I will show you the others later. It says switch port enabled because it is a layer 2 port. If we want to configure a routed port with the no switch port command, this would display differently. The administrative mode is dynamic desirable. Administrative mode is what we actually configured on the interface. And then below it, operational mode displays whether it is a trunk or access. Because switch 2's interface is a trunk, switch 1's interface became a trunk as well, thanks to DTP negotiation. Here on switch 2, you can see that both the administrative mode and operational mode are trunk. Now both interfaces are configured in dynamic desirable mode, so they will both form a trunk. The output of show interfaces switch port is the same on switch 1. And this time switch 2 also has an administrative mode of dynamic desirable. But once again, the operational mode is trunk, because both switches are actively using DTP to try to form a trunk. Even if manually configured as a trunk, an interface still sends DTP frames out of the interface. This time switch 2's interface is configured in dynamic auto mode. Switch port in dynamic auto mode does not actively try to form a trunk. It's more passive. It will tell switch 1, if you want to form a trunk, I'll form a trunk. But I'm not going to actively try to form a trunk. However, because switch 1 is in dynamic desirable mode, once again, a trunk will be formed. Switch 1's show interfaces switch port output is the same. And switch 2's shows an administrative mode of dynamic auto, and again, operational mode of trunk. One more example. Switch 2's interface is now manually configured as port mode in the trunk. Switch port in dynamic desirable mode will actively try to form a trunk with other Cisco switches. It will form a trunk if connected to another switch port in the following mode: switch port mode trunk, switch port mode dynamic desirable, or switch port mode dynamic auto. Let's see how that works. Switch 1 and switch 2 are connected via their G00 interface. Switch 1's G00 interface is in dynamic desirable mode. Switch 2's G00 interface is manually configured as a trunk. So these two switches will both agree to operate as trunks. Here is a new command: show interfaces G00 switch port. These are just the first few lines of output. I will show you the others later. It says switch port enabled because it is a layer 2 port. If we want to configure a routed port with the no switch port command, this would display differently. The administrative mode is dynamic desirable. Administrative mode is what we actually configured on the interface. And then below it, operational mode displays whether it is a trunk or access. Because switch 2's interface is a trunk, switch 1's interface became a trunk as well, thanks to DTP negotiation. Here on switch 2, you can see that both the administrative mode and operational mode are trunk. Now both interfaces are configured in dynamic desirable mode, so they will both form a trunk. The output of show interfaces switch port is the same on switch 1. And this time switch 2 also has an administrative mode of dynamic desirable. But once again, the operational mode is trunk, because both switches are actively using DTP to try to form a trunk. Even if manually configured as a trunk, an interface still sends DTP frames out of the interface. This time switch 2's interface is configured in dynamic auto mode. Switch port in
Trunk.
dynamic auto mode does not actively try to form a trunk. It's more passive. It will tell switch 1, if you want to form a trunk, I'll form a trunk. But I'm not going to actively try to form a trunk. However, because switch 1 is in dynamic desirable mode, once again, a trunk will be formed. Switch 1's show interfaces switch port output is the same. And switch 2's shows an administrative mode of dynamic auto. Again, operational mode of trunk. One more example. Switch 2's interface is now manually configured as an access port with the switch port mode access command. Switch 1 is actively trying to form a trunk, but since switch 2 is manually configured in access mode, the trunk will not form, and both will operate as access ports in the default VLAN, which is VLAN 1. The output of show interfaces switch port on switch 1 now shows an operational mode of static access. What does static access mean? Static access means an access port that belongs to a single VLAN that doesn't change, unless you configure a different VLAN. There are also dynamic access ports, in which a server automatically assigns the VLAN depending on the MAC address of the connector. But this is out of the scope of the CCNA. You don't need to learn about dynamic access. I just wanted to clarify what static access means. Now, on switch 2's G00 interface, both the administrative and operational modes are static access. Okay, now you've learned about dynamic desirable mode, and seen that an interface in dynamic desirable mode will use DTP negotiation to form a trunk if the connected interface on the other device is in trunk, dynamic desirable, or dynamic auto mode. However, if the other interface is in access mode, it will not form a trunk. It will be in access mode. Now let's look at dynamic auto mode. Switch port in dynamic auto mode will not actively try to form a trunk with other Cisco switches. However, it will form a trunk if the switch connected to it is actively trying to form. It will form a trunk with a switch port in the following modes. Switch port mode.
Port in dynamic auto mode will not try to with other Cisco switches. However, it is it simply from
Trunk or switch port mode dynamic desirable. So, switch 1's G00 interface is configured in dynamic auto mode, and switch 2's is manually configured as a trunk. Therefore, DTP negotiation will cause them to form a trunk link. Here you can see the administrative mode of dynamic auto, operational mode of trunk, whereas on switch 2, both are trunk. Now, we already saw what happens when a switch port in dynamic auto mode is connected to a switch port in dynamic desirable mode. They form a trunk. So let's look at two switch ports in dynamic auto. Neither is actively trying to form a trunk, so both operate as access ports in the default VLAN, VLAN 1. And they have the same output for the show interfaces switch port command, administrative mode of dynamic auto, and operational mode of static access. Next up, dynamic auto and access mode. As you can probably guess, this will result in both interfaces operating as access port. Here is the output of show interfaces switch port on each switch. Now, you may wonder what happens if a manually configured trunk is connected to a manually configured access port. Well, since both are manually configured, they are forced to operate mismatched, trunk and access mode. Here is the output of show interfaces switch port for each. However, this configuration does not work. It should result in an error, and traffic will not pass between. Here's a chart summarizing the resulting operational mode given two administrative modes. For example, a switch port in dynamic desirable mode will form a trunk with an interface in any administrative mode except access. Pause the video here if you want to take a look at one more important point. DTP will not form a trunk with a router, PC, etc. Switch port will be in access mode. So if you want to configure router on a stick, for example, you must manually configure the interface connected to the router as a trunk. You cannot put it in dynamic desirable mode and expect it to become a. Let me cover a few more points about DTP. On older switches, switch port mode dynamic desirable is the default administrative mode. It will actively try to form trunk. However, on newer switches, switch port mode dynamic auto is the default administrative mode. You can disable DTP negotiation on an interface with this command. Switch port no negotiate. If you want to configure router on a video here. Switch port mode dynamic desirable is the default administrative mode. It will actively try to form trunk links. However, on newer switches, switch port mode dynamic auto is the default administrative mode. You can disable DTP negotiation on an interface with this command. Switch port no negotiate. If you use this command, the interface will stop sending DTP negotiation frames. By the way, configuring an access port with switch port mode access also disables DTP negotiation on it. It will also stop sending DTP frames. If you manually configure an interface in trunk mode, however, it does not stop it from sending DTP frames, unless you also issue the switch port no negotiate command. As I said before, it is recommended that you disable DTP on all switch ports and manually configure them as access or trunk mode. Now let me talk about trunk encapsulation negotiation. Switches that support both .1Q and ISL trunk encapsulation can use DTP to negotiate the encapsulation they will use. This negotiation is enabled by default, as the default trunk encapsulation mode is switch port trunk encapsulation negotiate. I mentioned this in a previous video on VLANs. If you want to manually configure a trunk interface on a switch that supports both .1Q and ISL, you must first change the encapsulation mode to .1Q or ISL. You can't leave it in negotiate mode. ISL is favored over .1Q, so if both switches support ISL, it will be selected. By the way, the DTP frames that DTP uses to negotiate are sent in VLAN 1 when using ISL, or in the native VLAN when using .1Q. The default native VLAN is VLAN 1, however, so unless you change the native VLAN, they will be sent in VLAN 1 for .1Q also. To show you this negotiation of trunking encapsulation, here is a little more of the output from show interfaces. Switch port. I set the interfaces on both switches to dynamic desirable mode, so they would form a trunk. Notice that the default trunking encapsulation mode of negotiate results in an operational trunking encapsulation of ISL. By the way, this field down here, negotiation of trunking, shows whether DTP is enabled, whether the interface is sending DTP frames or not. If the interface is in dynamic desirable, dynamic auto, or trunk mode, this will be on. If it's in access mode, or if you use the switch port no negotiate command showed you before, this will be off. Okay, that was a good deal of information about DTP. I'm quite sure that you won't need any more information than that for the CCNA when it comes to DTP. If you need extra review, watch the section again, try out the configurations in Packet Tracer yourself, and then try my packet tracer practice lab, which will be in the next video. Next, let's move on to today's second topic, DTP, VLAN trunking protocol. VTP allows you to configure VLANs on a central server switch, and other switches, called VTP clients, will synchronize their VLAN database to the server. It is designed for large networks, many VLANs, so that you don't have to configure each VLAN on every single switch. However, like DTP, it is rarely used, and it is recommended that you do not use it. I will show you one reason why it is recommended that you do not use it later. There are 3 versions of VTP, 1, 2, and 3. Most modern Cisco switches support all 3, but older switches might only support 1 and 2. I will talk about some differences in each version. There are 3 VTP modes that a switch can operate in: server, client, transparent. Cisco switches operate in VTP server mode, but some difference is certain protocol. VTP allows you to configure VLANs on a central server switch, and other switches, called VTP clients, will synchronize their VLAN database to the server. It is designed for large networks with many VLANs, so that you don't have to configure each VLAN on every single switch. However, like DTP, it is rarely used, and it is recommended that you do not use it. I will show you one reason why it is recommended that you do not use it later. There are 3 versions of VTP, 1, 2, and 3. Most modern Cisco switches support all 3, but older switches might only support 1 and 2. I will talk about some differences in each version. There are 3 VTP modes that a switch can operate in: server, client, transparent. Cisco switches operate in VTP server mode by default. Let's talk about the different VTP. First up, VTP servers. They can add, modify, and delete VLANs. As I said, Cisco switches operate in VTP server mode by default, so you can modify the VLAN database on Cisco switches by default. They store the VLAN database in non-volatile RAM, also called NVRAM. This means the VLAN database is saved, even if the switch is turned off or reloaded. VTP servers will increase the revision number every time a VLAN is added, modified, or deleted. This revision number is a very important part of VTP. It's what VTP uses to determine the newest version of the VLAN database, the version that the switches will synchronize. DTP servers will advertise the latest version of the VLAN database on trunk interface, and the VTP clients will synchronize their VLAN database to it. So, VTP advertisements aren't sent on access, only trunk. Here's another important point. VTP servers also function as VTP clients. What does that mean? It means that a VTP server will synchronize to another VTP server with a higher revision number, because the highest revision number is considered the newest, most accurate version of the VLAN data. Now let's talk about VTP clients. VTP clients cannot add, modify, or delete VLAN. If you try to add, modify, or delete a VLAN in the CLI, command will be rejected. VTP clients do not store the VLAN database in NVRAM. However, in the newest VTP version, DTP V3, they do. VTP clients will synchronize their VLAN database to the server with the highest revision number in their VTP domain. I will talk about VTP domains. Finally, DTP clients will advertise their VLAN database and forward VLAN advertisements to other clients over their function. Okay, that's enough information for now. I will talk about the third VTP transparent later. So let's look at how a VTP works. These are 4 switches, and I've configured all of their interfaces as front. They will send and receive VTP advertisements between each other. Here is the output of a very useful command. Show DTP status. All of these switches have the default configuration, so their output will be mostly the same. Let's look at some of these fields. These fields here show that the switch is capable of running DTP version 1, 2, or 3, but it is running version 1 at the default. Notice that there is no domain name. By default, the domain name is null. There is no domain. If we want VTP to synchronize among these devices, you will need to configure them all with the same VTP domain. Now look down here. You can see the default VTP operating mode of server. Notice the maximum number of VLANs supported locally is 1005. This is because VTP version 1, version 2 do not support the extended VLAN range of 1006 to 4094. Only version 3 supports them. So if you want to use the extended VLAN range, you'll need to use VTP version 3. The number of existing VLANs is 5. Those are the VLANs that exist by default on the system. 1 and 1002, 3, 4, and 5. Finally, look at the configuration revision number. It is 0 at the moment. If I add, modify, or delete a VLAN, this will increase to 1. Which one will advertise this to VTP clients in the same domain. It will also update its own VLAN database if it receives a VTP advertisement with a higher revision number, because VTP servers function as clients also. So, I use the command VTP domain Cisco to change switch 1's VTP domain name to Cisco. I then made a VLAN, VLAN 10, and named it engineer. So because I added a VLAN, if I do show VTP status again, you should see that the revision number has increased. You can now see that the VTP domain name has changed to Cisco, the number of existing VLANs is 6, and the revision number has increased to 1. Now let's go check on the other switch. So because I added a VLAN, changed switch 1's VTP domain name to Cisco. I then made a VLAN, VLAN 10, and named it engineer. So because I added a VLAN, if I do show VTP status again, you should see that the revision number has increased. You now see that the VTP domain name has changed to Cisco, the number of existing VLANs is 6, and the revision number has increased to 1. Now let's go check on the other switch. Okay, so something interesting happened. Without any configuration, Switch 2 has changed its domain name to Cisco and updated its VLAN database to match Switch 1's with a revision number of 1. If a switch with no BTP domain, or domain null, sees a BTP advertisement with a BTP domain name, it will automatically join that BTP domain. So, Switch 2 automatically joins the domain Cisco. As I said before, if a switch receives a BTP advertisement in the same BTP domain with a higher revision number, it will update its VLAN database. If I do show VLAN brief Switch 2 now, you can see that VLAN 10 with the name engineering was added. Here you can see that the advertisements were passed along to Switch 3 and Switch 4 as well, and they joined the domain and updated their VLAN database. Since you've seen how BTP sync works, let me introduce one danger of BTP. If you connect an old switch with a higher revision number and the BTP domain name match, all switches in the domain will sync their VLAN database to that switch. This could cause all of the hosts on your network instantly lose connectivity, because the switches could sync to a totally different VLAN database, and the VLANs you were using could disappear. This is one reason why BTP is usually not used in modern networks. Just to demonstrate that, let's say this BTP domain Cisco has a revision of 5 in VLANs 1, 10, 20, 30, and 40. Then you take an old switch your company used to use, add to the network, however has a revision number of 50, VLANs 1, 99, and 220. We'll send BTP advertisements with this revision number, which will be forwarded throughout the domain. All of these switches will update their VLAN database, and all hosts in VLANs 10, 20, 30, and 40 will suddenly lose connectivity. Next, let me talk about BTP transparent mode. Switches in BTP transparent mode do not participate in the BTP domain. They do not sync their VLAN database to the BTP. BTP transparent mode maintains its own independent VLAN database and it can add, modify, or delete VLANs, but they won't be advertised to other switches. Although it doesn't sync its VLAN database, it will forward BTP advertisements over its trunk port if the BTP advertisement is in the same domain as it, but it won't advertise its own VLAN. So let's compare the functionality of server, client, and transparent mode switching. I set switch 2 to client mode with the command DTP mode client. Afterward, I tried to create VLAN 20 on the switch, but as you can see, I was rejected because switch 2 is now in client mode. Then I set switch 3 to transparent mode with BTP mode transparent. Also, to show you that a transparent mode switch won't forward advertisements if it's in a different domain, I changed the domain name to So I created VLAN 20 named sales on switch 1. And you can see it appears in the output of show VLAN green. Then I did show BTP status. And you can see that the configuration revision number is 4. Should be 2, I think, but I made a few other changes. I was trying things out in the lab. Anyway, let's check out switch 2. As you can see, the VTP client switch 2 has indeed added VLAN 20 to its VLAN database. And it now has the same revision number, 4. How about the transparent switch 3? As expected on the transparent switch 3, VLAN 20 was not added. And now it has a revision number of 0. Changing the VTP domain to an unused domain will reset the revision number to 0. Changing the VTP mode to transparent will also reset the revision. So if you're going to plug an old switch with a high revision number into a network that uses VTP, make sure to reset the revision number, one of these methods, so it doesn't overwrite your network speed. Now the question is whether switch 4 will have added VLAN 20 to its VLAN database. Remember, switch 3 is in transparent mode in a different domain, so it shouldn't forward the BTP advertisements to switch 4. Indeed, switch 4 does not have VLAN 20, and it is still on revision number 3. So what can we do to make switch 3 start forwarding the VTP advertisement to switch 4? If we change the VTP domain on switch 3 back to Cisco, it should start forwarding advertisements to switch 4, even though switch 3 itself won't sync its own VLAN database based on those advertisements. So I changed the VTP domain on switch 3 back to Cisco. I also created some new VLANs on switch 1 to increase the revision number and more advertisements. And now you can see that switch 3 did indeed forward the advertisements to switch 4. Switch 4 synced its VLAN database to switch 1 and switch 2. Finally, I'll just talk about VTP version. To change the VTP version, I'll just switch 1 and switch 2. Change the VTP version, use the VTP version command. Changing the VTP version increases the revision number, and advertisements with this new revision number will be sent. Other servers and clients will then sync and start operating in version 2 as well. For example, here is switch 4. It is now running version 2 and has a revision number of 13, just like switch 1. As for the difference between DTP version 1 and 2, here's a quote directly from Cisco. DTP v2 is not much different than DTP v1. Major difference is that DTP v2 introduces support for token ring VLANs. If you use token ring VLANs, you must enable DTP. Otherwise, there is no reason to use VTP. Token ring is an old technology, so really, there is no reason to use version 2. As for version 3, it has quite a few differences and new features, but it's certainly beyond the scope of the CCNA, so we'll leave it here. Okay, here's the first slide on DTP. To be honest, there is still lots more I could talk about regarding DTP, but I will leave it at that for this course. Again, it isn't on the exam topic, but you may get some basic questions about DTP and its purpose, so I wanted to tell you about some of its functions. If you learn and remember the information I've given you in this video regarding DTP, that should be more than enough for the CCNA. Basically, just know the purpose of DTP, the differences between server, client, and parent mode. Know that switches operate in server mode by default, and that servers operate as clients too. Know about revision number. If you know all of that, you'll be fine. So before moving on to today's quiz, let's review what we covered. We looked at DTP first, which is a protocol that allows Cisco switches to form trunk connections with other Cisco switches without manual configuration. However, it's recommended that you disable this protocol for security purposes. Then we looked at VTP, another Cisco proprietary protocol that allows you to configure VLANs on switches that operate as central VTP servers, which then advertise their VLAN database, and VTP client switches sync their database to it. Note that VTP only syncs the VLAN database. You still have to configure the interfaces on each switch separately. For example, switch port access VLAN 10, etc. VTP does not automatically assign interfaces to VLANs. Both of these protocols are no longer on the exam topics list, but you should know about them and their basic function. You may get questions about them on the. Okay, let's move on to today's quiz. Bonus, I will also feature one practice question, Boson's XSIM for CCNA. A set of practice exams I highly recommend you get here this. The connected interfaces are operating as access.
Which one and switch to are both is and the connected are open ports. However, switch to power switches, you temper switch to old switch. To reset the configuration, what could
This is on old switches, default with switch port mode count. B. Interfaces on old switches, default with switch port mode dynamic desirable. Or C. Access ports are a feature of newer switches.
Okay. Mode.
Video fitting. So in this case, switch 1's interface is probably in dynamic auto mode, and the old replacement switch's interface is probably in dynamic desirable mode. So they would form a trunk. Let's go to question 2. Switch 1 is connected to switch 2, and switch 2 is connected to switch 3. You want switch 2 to forward switch 1's VLAN database information to switch 3. But you don't want switch 2 to synchronize its VLAN database to switch 1. Which command should you use on switch 2? A. VTP mode transparent. B. VTP transparent mode. C. VLAN mode transparent. Or D. DTP mode client. Pause the video to think about your answer. A. Parent mode will forward VTP advertisements, but it won't sync its VLAN database to the VTP server. It also won't advertise its own VLAN database. Let's go to question 3. What are 2 methods to reset a switch's VTP revision number to 0? Choose 2. Each answer is a complete solution. A. Change the VTP domain to an unused domain name. B. Change the switch to VTP server mode. C. Change the switch to VTP transparent mode. Or D. Use the VTP reset command. Pause the domain name. The answers are A. Change the VTP domain to an unused domain name. And C. Change the switch to VTP transparent mode. Either of these methods will reset the revision number to 0. This is useful with adding a switch with a higher VTP revision number to a network. Okay, now let's go to today's boson-Exim question. For today's boson-Exim practice question, I've selected not a multiple choice question, but a drag and drop. So this is about DTP, Dynamic Trunking Protocol. Select the VLAN trunking operational modes from the left, access, trunk, and also misconfig. Drag them to the resulting trunking configuration. So here we have one end of the connection.
Access dynamic auto access dynamic desirable access strong X dynamic auto access dynamic auto access dynamic desirable strong dynamic auto strong dynamic desirable access dynamic desirable dynamic auto strong dynamic desirable strong desirable strong access X strong dynamic auto strong dynamic desirable dynamic strong.
Start on your own. Let's walk will result in operational motives.
Yes.
The
Access
other end is trunkless.
strong
Also,
access
this trying to form a trunk, this end will not. So that is access. Access and try it out in the last
config
dynamic auto and access.
Access.
Dynamic auto. Neither is actively trying to form a
Dynamic
trunk
auto
desirable. This end is actively trying to form a trunk.
access.
Neither is actively trying to form a trunk. So that will be Bennett will form a trunk. Same thing, dynamic auto
From
with the other
desirable access access. Desirable
dynamic
dynamic auto
desirable
from
and the trunk. And this one is
from access
okay. Next, we don't do
misconfig
this anymore.
from dynamic auto from
Trunk desirable, of course. And click on done. And then click on show answer. And if you don't want to check the answer yet, you can click on next, go to the next, and I did. But let's see if I got boson's explanation. You can read it if you want. And there are also references. The official cert guide by Wendell Odom, Volume 1, Chapter 8, Implementing Ethernet VLANs, and some additional reading from Cisco. I will link some reading from Cisco in the video description. Today's XSIM practice question, fantastic practice example. Please follow the links with the software on EchoTracer Practice Lab to help you practice the configuration.
and Port. Oof. Cisco property dynamic service status HTTP status. DTP is dynamic. What are the dynamic which dynamic desirable? Service only with Cisco default. Cisco switches default to dynamic based on default to dynamic. Which port in dynamic we try to which port in dynamic mode try to 1G00 is connected. Which 2G00? Which 1G00 administrative mode variable? Dynamic desirable wrong. Disable dynamic auto. Disable static access. Auto wrong. Wrong. Dynamic access. Static access. Yes. DTP is by default for switches interfaces. enable. Click DTP initial port and support. Switch port mode dynamic desirable. Click DTP in auto mode dynamic. Recommends that disable DTP negotiation on a support. Test or support mode. No. Negotiate. Report negotiate. Recommends that disable DTP strong encapsulation with patient type is report. Dynamic DTP strong encapsulation which encapsulate DTP dynamic strong other desirable. The first analysis color switches default. The first and order desirable for in dynamic mode. Side of form. Dynamic desirable and strong. DTP is by default enabled. Port mode. Port negotiation. Which port? Negotiate or DTP disable mode. Which port? Which port? Dynamic disable. DTP encapsulation negotiation. DTP or DTP lab. Finish for
Welcome to Jeremy's IT Lab. This is a free, complete course for the CCNA. If you like these videos, please subscribe to follow along with the series. Also, please like and leave a comment and share the video to help spread this free series of videos. Thanks for your help. Also, remember to download this practice lab from the link in the description and try it out yourself in Package. If you want more labs like these, I highly recommend picking up Boson's NetSim for the CCNA. Click the link in the video description to check it out. It's a network simulator like Package, but it's even better. You can use it up to CCNP level even, whereas Package Racer is too limited to do much beyond CCNA level. Here you can see all of the labs available in NetSim for CCNA. These are all detailed, guided labs that not only help you practice what you've learned, but really test your understanding. So I think NetSim is a fantastic study tool for the CCNA. If you want more practice relevant to what we're covering now at this point in the course, look here in the Network Access section. These labs about VLANs and trunking feature both DTP and VTP. Make sure to stick around to the end of this video for a preview of one of these labs. If you want to grab a copy of NetSim for CCNA, follow the link in the video description. I highly recommend it. Let's get started with today's lab. Basically, we'll go through some of the DTP and VTP configurations we covered in the lecture video. There are 4 VLANs in the lab: VLAN 10, 20, 30, and 40. We'll use VTP to share the VLAN configurations between these switches. So step 1 says to configure the switch ports connecting switches as trunks and disable DTP on them. So G01 on switch 1, G01 and G02 on switch 2, and G01 on switch 3. Let's go on switch 1. First, enter privileged exec mode with enable, then global config mode with cont. Then configure G01. Interface G01. Actually, before configuring it, let's check the current administrative and operational modes with this command. Do show interface G01 switch port. Okay, as I mentioned in the lecture, the administrative mode is dynamic auto by default, same as switch 2's G01 interface. So the operational mode is static access. Notice that negotiation of trunking is on, so DTP frames are indeed being sent out of this interface. Actually, let's go into Packet Tracer's simulation mode to see them being sent. I will click through here, and you should use G-Earth. And so 2 on 1. Config mode with this command. Do show interface G01 switch port. Okay, as I mentioned in the lecture, the administrative mode is dynamic auto by default, same as switch 2's G01 interface. So the operational mode is static access. Notice that negotiation of trunking is on, so DTP frames are indeed being sent out of this interface. Actually, let's go into Packet Tracer's simulation mode to see them being sent. I will click through here, and you should see lots of SDP frames being sent, some CDP frames, as well as some DTP frames. STP and CDP are other protocols that I will talk about later in the course. Actually, I think STP will be the topic of day 20's lecture video. So the point is, you can see DTP negotiation frames are indeed being sent out of the switchboard. However, because all are in dynamic auto mode, no trunks are formed. Now let's go back to real-time mode and return to the CLI. I'll configure a trunk mode. Switch port mode trunk. Now let's do the show command again. Do show interface G01 switch port. Okay, now both the administrative and operational modes are trunk. However, negotiation of trunking, DTP, is still on. Let's disable it. Switch port, no negotiate. Okay, let's check once more. Do show interface G01 switch port. Great. Now negotiation of trunking is disabled. Next up is switch 2. Enter privileged exec mode with enable, then global config mode with cont. Configurations on G01 and G02 will be the same, so I will configure both at the same time. Interface range G01 to 2. Now let's configure them as trunks and disable DTP. Switch port mode trunk, switch port no negotiate. And let's check. Do show interface G01 switch port. Okay, both modes are trunk and negotiation is off. Looks good. Next, G02. Do show interface G02 switch port. Same, looks good. Finally, let's configure switch 3. Again, enter privileged exec mode with enable, then global config mode, cont. Configure the interface, interface G01, switch port mode trunk, switch port no negotiate. And let's check. Do show interface G01 switch port. Okay, looks good. So step 1 is complete. Now we'll configure VTP. I'll return to switch 1. Let's exit out of interface config mode. Exit. And check the current VTP situation. Do show VTP status. The output looks a little different than in the iOS version I used in the lecture, but the same fields are here. Different switches or different iOS versions might have slightly different behavior and show slightly different output. So just be aware of that and adapt. DTP version displays as 2. However, down here, DTP V2 mode is disabled. So really, version 1 is up. The domain name is blank too, as expected. So let's configure it now. First, the domain name. DTP domain CCNA. And let's create the VLANs. VLAN 10, VLAN 20, VLAN 30, exit. Let's check again. Do show VTP status. So the domain name is CCNA, the number of VLANs is now 8, and the configuration revision number is 3, because it increased by 1 for each VLAN we created. Now, we haven't done any VTP configurations on switch 2 and switch 3. Do you think they will have added VLANs 10, 20, and 30? According to what I said in the lecture, they should. When they receive VTP advertisements from switch 1, they should join switch 1's VTP domain and sync their VLAN databases. Let's check on switch 2. First, get out of interface config. Exit. Do show VTP status. Indeed, it has joined the VTP domain, and the revision number is 3. Let's check the VLANs. Do show VLAN 3. There they are, VLAN 10, 20, and 30. Let's check switch 3 also. Exit. Do show VTP status. Looks like switch 3 has synced as well. Let's check the VLAN. Do show VLAN 3. So switch 3 has also added VLANs 10, 20, and 30 without any configuration. Next, for step 3, let's configure switch 2 in VTP transparent mode and add VLAN 40. So set the VTP mode with this command. VTP mode transparent. Now let's add VLAN 40. VLAN 40. Exit. And let's check VTP. Do show VTP status. So the revision number is now 0 because it's in transparent mode. The number of VLANs is now 9. It kept the VLANs it synced from switch 1 before, but now it has added VLAN 40. Do you think switch 1 and switch 3 have added VLAN 40 now? They shouldn't, since switch 2 is in transparent. Let's check on switch 1. Okay, let's check the VLANs. Do show VLAN 3. As expected, no VLAN 40. Let's go on switch 3. Do show VLAN. Again, no VLAN 40. That's because switches in VTP transparent mode don't send VTP advertisements. Although switch 2 will forward VTP advertisements between switch 1 and. Let's go to step 4. Configure switch 3 in client mode. We're on switch 3 now, so let's do it. VTP mode client. Now let's try to add another VLAN. VLAN 50 here on switch 3. VLAN 50. As you can see, we are not allowed to configure new VLANs on switch 3, now that it is in VTP client mode. So if we want to add new VLANs on switch 3, we have to configure them on switch 1, which will advertise the changes to switch 3, which will then sync its VLAN database. Finally, let's do step 5. Configure the switch ports connected to end hosts in the correct VLANs, configure them as access ports, and check if DTP is still enabled on them. Starting here on switch 3, F01 in VLAN 10, 2 and 3 are in VLAN 30, and F04 is in VLAN 20. Interface F01. Before I configure it, let me check if DTP is enabled. Should be. Do show interface F01 switch port. As you can see, negotiation of trunking is on. So switch 3 will continue sending DTP frames to PC5, even though it will never form a trunk here. Now let's configure it.
P4
Switch port mode access,
5D.
switch port access VLAN, and let's see if that disabled DTP. Do show interface F01 switch port. So as you can see, manually
As you
configuring
can
an access
see,
port with the
I
command
like that.
switch port mode access does indeed disable DTP. Negotiation of trunking is now off. Now that we've confirmed that, I'll just quickly run through the rest of the configuration. Interface range F02 to 3. Switch port mode access. Switch port access VLAN 30. Interface F04. Switch port mode access. Switch port access VLAN 20. Okay, next up, switch 2. Interface range F01 to switch port mode access. Switch port access VLAN 40. Okay, and finally switch 1. That's all for this lab.
We configure the type on this DTP and VTP lecture that we do earlier. For the step here, we have film 10, film 20, film 30, and film 40 again. For the step here, and the step, we have to configure the switch port connecting switches as trunk ports, disable DTP on the ports, confirm the administrative and operational mode of each. The first thing that we do, we have to configure the switch port connecting switches as trunk port. Well, domain lock. Enable NFT interface D01 port. It do show interface. Unit of trunking on ADHD which port and in here we move into each the easier. Now, um one switch to is still on DTP. Negotiation trunking. And it is for position of trunking. Now we moving on full config is the one range 0 for trunk surface for one surface is range 0 1 figure switch 1 and VTP domain CCNA get VLAN stand 30 switch 1 F switch 2 and switch 3 added VLAN stand 20 and 30. Figure the VTP push be brief.
Let's move on to take a look at boson next. A little different than in the ITP version or
To show it the status. Using the reference DTP operating mode server DTP domains DTP domain we create VLAN 10 20 and we see for the other already added the VLAN step to show and brief at the content when entered figure switch to NVTP transfer add VLAN for it to each VLAN for it and database configure VLAN VTP. And added for VLAN database switch. Okay. VLAN for will be added to one. It will not be added because the switch 2 is operating as transparent mode, so it will not be sending any recently updates on the other switches. And for the switch 3, we can, if VLAN 4 is added to the VLAN table, and configure the switch 3 in DTP client mode, try to configure VLAN 50 on switch 3. Is it added? 3. The mode on to client mode DTP client, and now we added VLAN says VTP VLAN configuration not allowed when device is client mode. Configure all switch port connected to a host and direct VLAN. Manually configure them as ports. DTP switch number on ports. And switch to two will be in VLAN 10. Put up on 10.
For different types of current VLAN 3, use current electronic roving and quickly switch that port. The next finally switch port access and VT pose up. So
Dash 10. This DTP is still enabled on switch. Switch. Okay. Now we move into so let's switch. And negotiation function because the administrative is dynamic will be sending the DTP frames output interface. If we change to export, it will be off. Negotiation of trunk off. Can change it to 03. So when 03 it's the decision of companies. Figure out this 0 is S 01 process. And
Set your access VLAN 10. Switch DTP VLAN 20. Okay, so in this lab, we took a look at DTP and VTP configurations. That's all for this lab. Let's move on to take a look at Boson NetSim for CCNA. Okay, for today's Boson NetSim lab preview, I've chosen a fairly simple lab, configuring VTP client mode on switches. As you can see here, there are quite a few of these Boson NetSim guided labs provided for you. And some of them are quite complex, quite difficult, but some of them are more simple. So just to show you that, I have chosen one of the more simple labs today, configuring VTP client mode on switches. I've already loaded it, so I'll just go on lab instructions. The objective: configure VLAN trunking protocol, VTP on a switch. Test VLAN updates from one switch configured as a VTP server. Prevent the second switch from creating VLAN. And here is the topology. Two switches connected with two interfaces, fast Ethernet 11, fast Ethernet 12. Here are the commands you need to know to complete the lab. Ethernet 12, connected with two interfaces, fast Ethernet 11, fast Ethernet 12. Here are the commands you need to know to complete the lab, and a summary of the IP address. So there are 9 steps to this lab. Let's do the first 6 of it. So configuring a VTP. So step 1, configure switch run with the appropriate host name. Configure fast Ethernet 11 and 12. You always be. So I am already in the CLI of switch. So let's do enable T and set the host name. Host switch 1. Okay, and then fast Ethernet 11 and 12 to always be trunk. Interface range F011 to 12. First, let's check the operational name. Do show interface F011 switch ports. Okay, so it is already in dynamic desirable mode and operating as a trunk. But we want to configure it to always be a trunk, so we will manually configure it as a trunk. I assume fast Ethernet 012 is also. Yes, it is. Okay, so let's configure them to always be a switch port. Yes, it is. Okay, so let's configure them to always be a switch port mode trunk. And let's check fast Ethernet 11, administrative mode trunk, operational mode trunk, and fast Ethernet 12 is the same. Okay, next step 2 is do the same thing on switch 2. So here under devices, click on switch 2 and click on console to access the CLI. Enable T hostname of switch 2, interface range F011 to 12, switch mode transfer. And I'll check show interface F011, switch ports. So I forgot the do that. So if you're in this situation, you want to return to the beginning of the command, type do or type no to cancel it. Let's hit Control A on your key. And type do space. Okay, administrative and operational mode. So this. So I forgot the do, but administrative and 012. Okay, on switch 1 and switch 2, configure the VTP domain name to be Cisco. So let's do that. I'll exit out of interface configuration mode. Let's check the current VTP. Do show VTP status. Okay, so it already has a VTP domain name pre-configured, big domain. If this was null, actually let's check on switch 2 also. Do show VTP. Same, okay. So it was also pre-configured in big domain. If both of them didn't have a domain, if you configured the VTP domain on one of them, the other would then sync to that and change its domain name to that name. But because they are already pre-configured, you have to configure the domain name on both. So VTP domain Cisco. Okay, and switch to also VTP domain Cisco. There you go. Okay, on switch 1, verify that the switch is configured as a VTP server. So we'll do that same show command, do show VTP status. Yes, it is in the default operating mode of VTP server. Configure switch 2 as a VTP client. It also is a server, so VTP mode client, and let's verify. Again with the do show VTPs. Okay, so it has changed to operating mode of client. Okay, so there are a few more steps in this lab, but I will leave it here for today. If you want to get a copy of NetSync, please follow the link in the description. Again, you can enter password. VTP that I didn't mention in the lecture video. It's the VTP password. A switch will reject any VTP advertisement if the password doesn't match. So let's go back on switch 1. I'll set the password with this command, VTP password, and I'll make it Cisco. Now let's make another VLAN, VLAN 50, exit. Do show VTP status. So the revision number is now 4, and the number of VLANs is 9. Let's go see if switch 3 accepts this advertisement. Do show VTP status. So switch 3 has a revision number of 3 and 8 VLANs. It has not accepted the advertisement. What if I set an incorrect password? VTP password CCNA. Do show VTP status. It still doesn't accept the advertisement. Now let's set the correct password. VTP password Cisco. Do show VTP status. Okay, you can see switch 3 has now accepted the advertisement and synced with switch 1. Just wanted to show you that extra feature of VTP. That's all for this lab. Thank you. Welcome to Jeremy's I.